Welcome to this latest Acuvate webcast, and today we're going to talk about the various Acuvate activities in the manufacturing space, with a focus very much at asset management in the manufacturing space. There's a very broad spectrum, and we've got a broad offering in that space. So in this webcast for the next 45 minutes, we're really going to focus at that activity. Let me first introduce myself. I'm Johan Krebbers. I'm the CTO for Acuvate. So very much welcome to this webcast. Here you see the agenda of today. We'll first focus a little bit about Acuvate itself, then about our 7 steps approach from collecting data to visualizing data. Then we're going to talk about our activities in the asset management space. And then we're going to talk about ontology developments we do, because it's also closely linked to asset management and the options for manufacturing we see from an ontology point of view. First, about Acuvate. Acuvate is a system integrator. We've been in the market for about 17 to 18 years. We're about an over 500 people company, and we've got 3 practices. The first practice, which is the focus of today, is the data analytics practice. And it's all about, I'm going to talk to you in a moment what the cover, but the truth is all about collecting your data sources, manipulate the data, bring it to an enterprise data AI factory, visualize the data, manipulate the data, apply AI to that data. So it's a whole spectrum of collecting data and manipulating data. Then with AI and automation, it's very much about what we can do with chatbots, with Copilot, with GenAI in the various scenarios. And then the third one is about optimization, renewal of your applications out there. We are a system integrator, so we're not a product company. Our focus is very much at accelerators. And you see some of our accelerators at the top of the slide. An accelerator is a tooling we have developed to speed up activities. We're going to talk about the Acu7 accelerator. We're going to talk about the Acuprism accelerator. We're going to talk about the AcuNow accelerator. We also have Acuvate to speed up the migration from your Tableau dashboards, Salesforce Tableau dashboards to a Microsoft Fabric Power BI environment, as an example, to almost fully automate that whole process. So Accelerate is all about speeding up activities. And then you see our customer base. Our prime focus from a vertical point of view is the energy market, is the manufacturing space, and is the CPG space. As a system integrator, we also work in other verticals. But if you look at where we do our business developments, developing new solutions, new capabilities, is very much in the energy space, manufacturing space, and in the CPG space. Our customer base is around the world. We have customers, as you see over here, in the US, in Europe, Middle East, some in Asia as well. Our global technology center is based in Hyderabad, in India. We have our people, also our staff, based in Europe, in the UK, to cover Europe, in the US, and in the Middle East, in Dubai. So this is all about Acuvate. Let's now talk about our solutions. First, we're going to talk about Acu7. Acu7 is really the underpinning of what we're doing. It's at the high level. It's all about, on the left, the number one, based on a business problem. What kind of data do I need to collect? Do I need to collect data from an ERP environment, from my OT environment, from a time series environment, or anything else? So once I've collected data, how do I collect the data? What sensors do I need? How do I collect the sensors? Do you add environment a number 3, or direct to number 4 to your enterprise data and AI platform? And so that's all about data. Now your data number 4, if the data gets to number 4, you can think about data contextualization. You can think about your medallion architecture, where you go from bronze, silver, and gold to gold. So it's all about data. Data in itself has no value. You're only getting value out of the data once you start applying analytics to the data number 5. It can be very simple analytics, can be very sophisticated AI-driven analytics, but it's all about value out of the data, and then you integrate the results of that in number 6 into your business processes. That can be in the chatbots, that can be a digital twin, that can be dashboarding, can be anything. And then 7 is the final decision making. So we as a system integrator cover this whole space. We do that with partners, where we take full accountability of collecting data and storing the sensors and also manipulating the data and making the data visible in various ways. So that's our end-to-end story from a data and AI point of view. And of course, here you see some of the coverage of the solutions over here. It's important also to realize when you talk about data collection, we also talk about the OT space. I mean, the OT space is very important in manufacturing. It's where you run your facilities. It's a secure environment. It's separate from your IT environment, but still the data you collect over there, you want to make available to the rest, to your analytics setup, and want to integrate with the rest of your data. So that's OT space is important. And of course, as I mentioned, data can be collected from many different sensors, from other data sources, from your ERP system, from your SAP, from your Maximo, whatever your systems are, of course. So let's now look at the main building blocks when we talk about asset management in the manufacturing space. On this particular slide, you see the building blocks we're going to detail in a moment. You see in the middle, AcuPrism. That's really where all the data, that's our enterprise data and AI platform. That's where all the data comes together. It's either based on Fabric, Microsoft Fabric, or based on Databricks, depending on what your environment is. You see also over here on the right, our digital twin solution, because that's where you visualize your asset information in either a 2D digital twin solution or a 3D digital twin solution. The one you see over here, we're going to explain in a moment, is the 3D digital twin solution. On the left, you see how we collect the data from the various data sources. We have some special interfaces over here, specific for manufacturing. I'm going to explain in a moment. That's really where you collect the data and bring it to your AcuPrism environment. And on the top right, you see Diagram IQ. It's really where we have our tech register for the enterprise. We'll keep track of all the tech information. I'm going to also explain in a moment. And of course, you see then also there our enterprise semantic model, and on top of that, our ontology services, which we're also going to discuss. For each of these items, we will discuss in more detail because they're all part of our end-to-end asset management solution. So number one is of course we have developed a special interface for picking up your Pi, Aviva, OSIsoft Pi streaming data, your Pi time series streaming data, and stream it real time to AcuPrism environment. That's number one. We also have number two. We have our Diagram IQ, where we have an enterprise tech register, where we keep track of all the tech-related information and a clear link to your EDMS environment. You see in the top right corner the detailed information. You saw the one I just spoke about was really the interface to your EDMS environment. So in your tech ID, you have for every tech register, for every tech ID in your tech register, you have exact information. What are the relevant drawings I need to know about? What are my electrical drawings, my engineering drawings, my instrumentation drawings, my HSC drawings, my cabling drawings, you name it. Yeah. Sorry, let me go back to this one. And the last one is Aviva Pi time series, all the data sources are all stored. So we bring all the data sources together, we collect all data sources, we have interface with these data sources and collect them to the AcuPrism environment. Then you're talking about the top left corner, AcuNow. AcuNow is our accelerator for edge facilities. If you need real-time decision making, you need edge facilities, and we bring them to the market under the AcuNow accelerator, and we explain them in a moment in more detail. And then we also at the top, you got AcuPrism on the right. And AcuPrism, of course, is really where we bring all data together. We contextualize the data. We have the bronze, silver, and gold layers of the data, and also we apply AI to the data. And it can be machine vision, can be machine learning, can be Gen AI, can be agentic AI, can be just agents, you name it. What we do to the data to get value out of that data. And the last is you see a Microsoft Fabric Planning. Microsoft Fabric Planning is a new service from Microsoft. It's only in preview at the moment, but on top of the ontology data, it helps you to do future planning of your business. So if you want to know how your business is going to develop in the next 1, 2, 3, 4, 5 years, then Microsoft Fabric Planning is a solution for that. Still in preview, but it's very important if you want to really start thinking about future planning of your business. So you don't look backward, but you look forward and how the plan is going to look like, what it means to your business. So these are the story behind each of these blocks. You see them the same numbers over here. Let's now go to in more detail. Let's first talk about AcuPrism. AcuPrism is our enterprise data and AI platform. You see here the green box in the middle, number 7, and that's either Microsoft Fabric based or Databricks based. You bring your data source together over here, any type of data source, you load it into the OneLake data platform or in the Delta Lake platform from Databricks. You store it in an open source format like Parquet format, and then you make that. So you store all the data you have in that environment. You bring it together over there, and they align the data source over there. So you contextualize the data because often you get the data in silos with different naming conventions from the different sources, and you align all of that in the green part. So the green part is the centerpiece where you bring data together, you manipulate the data, you apply AI to the data to make it ready for visualization. And here you see sorry, I need to go back one slide. Here you see the proper slide of what we call the AcuPrism environment. But I already have explained the components over here. As I mentioned, we got 2 implementations. We got one for Databricks. If you already are in a Databricks environment today, then of course you would like to stay over there. We do support AcuPrism in a Databricks environment. If you're not yet a Databricks shop, but you already are thinking about Microsoft Fabric, it can help you implementing and customizing Fabric, of addressing Microsoft Fabric for your environment, and give you the same capabilities based on AcuPrism, but then in the Fabric space. So we have a flavor on Databricks, we have a flavor on Microsoft Fabric. The capabilities are the same. Which one to choose for is very dependent on your environment, where you're coming from, and where you want to go to. Let's now talk about the data source on the left. It really falls under the name of AcuNow, the AcuNow Accelerator. So here you find the various data sources. I'm going to explain in a moment where you collect the data, your sensors, your applications, and then bring the data into AcuPrism. If we're talking about that environment, we have 4 flavors of AcuNow. You see at the top under number 1, where we're using Fabric RTI, the real-time intelligence. And RTI is all about bringing streaming data. It can be time series data, can be temperature data, but these are short, small messages from your various assets. It can be from your pumps, can be from your engines, whatever it's coming from, but it can come from different environment, and bring it to the Fabric environment, then load the data there in your KQL data source, and then have various capabilities to check the data, validate the data, and raise alarms when the data is out of spec, for instance. So that's number 1. Number 2 is really about when you say, I have large amounts of data, I need real-time decision making, but I have only a small number of edge devices. The number 2, Microsoft Azure I2 Edge is there for simple edge implementations. So small, when you have as a company a small number of edge devices, but you want to run AI in that environment, for instance, then Microsoft Azure I2 Edge is your underpinning solution. Number 3, if you say, if I have a large number, maybe hundreds of edge devices in my company, then I need a better way to manage these devices. And then Microsoft Azure IoT Operations is your solution. Again, it's meant for running in an edge environment, but if you have an enterprise with a large number and you want to manage these devices, then Microsoft Azure IoT Operations is your way forward. And number 4 is all about our special solution, which we only bring to the market. If you got Aviva OSIsoft.py interfaces on many locations and you want to stream that data real time to your enterprise data platform, then we offer an interface for Acuvate, for Aviva, called the Acuvate RTDIP PI streaming interface, where we stream the data real time, really real time, from an OT environment into your Fabric or your Databricks environment. So these are the 4 flavors we have of Acu now. So number 1, real-time streaming of data directly from your sensor to Fabric. 2, if you have a small number of edge devices, then you use Microsoft Azure to Edge. Number 3, if you have a large number of edge devices, so complex environment, you very much use Microsoft Azure I2 Operations. And number 4, if you have high-speed streaming coming from Aviva OSIsoft by historians or other historians, you can also support and bring that into your AccuPrism environment. In the next couple of slides, I worked it out in more detail. I will go through that now because I summarize. You can read this at your leisure. Here you see RTI, what the main building blocks are of RTI, the high-level architecture, the general architecture, with some explanation to go with it. Here you see Microsoft Azure I2 Operations. So in the middle you see the software installed on your edge device, and the edge device, of course, can be in GPU, NVIDIA device, but can also be an HP or Dell Intel device. But this is really this is meant for a large number of edge devices. So this is all about all of what you see over here is really coming back into your Acu Now environment, the Acu Azure Accelerator, which we bring to the market with the 4 scenarios I saw, all about I need real-time decision making. I bring the data to my edge environment or very quickly to the cloud environment. I immediately apply AI to get real-time decision making going. This is the solution we bring to the market for your Aviva PI or OSIsoft PI historians at your OT sites, at the sites where you have your refineries, your production sites, your chemical plants, or you have your Aviva or PI historians where you're collecting time series data, and we stream that real time to your AccuPrism environment over here. And once it's over there, you can use that data for analytics, for principal predictive maintenance, what have you. I will talk about that in a moment. Here you see some further explanations of the special features of this interface. It's fully resilient. That means if you're losing data for whatever reason, you lost the connection maybe for a short period, when you restart, it will pick up the data from when you missed it. So you won't lose any PI time series data. We've implemented this in Adura. Adura is a joint venture between Shell and Equinor in the UK. It owns all the offshore platforms in the United Kingdom. It went live in September last year and collects all the data from the Aviva and OSIsoft PI historians into a single AccuPrism environment, as explained on previous slide. It's a Databricks AccuPrism environment. It's up and running since September last year, so for well over 6 months. Here you see the setup over here. In the middle left, you see Databricks with our solution on top of that. Now let's go to the next part. The next part is DargMRQ. And DargMRQ is really our asset, our tag register. And let me show you more information about it over here. Every tag, so every asset will have a tag ID. A tag ID is just a label with a number. You see it on the example on the right over here. It identifies that asset. And that asset can be an engine, can be a pump, can be part of a pump, can be a compressor, can be part of a compressor. They all have tag IDs. So they all are, and these tag IDs are the unique identifier used in every system to link to that particular device. So it can be engines, can be pumps, can be conveyor belts, can be bottling lines, can be compressor, can be turbines. They all will have that unique tag ID. It's important that these are available, and it's important that these are well maintained. And that's one of the big problems in the manufacturing space, that these tech IDs are poorly maintained. So people hardly know which tech IDs are used where, what are the drawings to go with these tech IDs. And that's why we're bringing to the market Diagram IQ to address that whole problem out there. Because what you see happening in reality, that this tech information is often stored in one or more Excel spreadsheets with no change management, with no change control. And often we have multiple change Excel spreadsheets. You find in Excel spreadsheet the tech IDs, which information is not linked to anything, is poorly maintained, is out of date. What does that mean? It means that when I look at the pump and I find the tech ID on that pump, I see the tech ID, and I now want to know what is the PIN ID to go with the tech ID, what are the electrical drawings go with the tech ID, or what are the cabling drawings. I can spend hours to find a relevant drawing because I didn't maintain the link between your tech IDs and your drawings in your drawing management system. So an engineer in several companies often spends a lot of time to say, okay, I found the tech ID, I need to fix that problem. If I'm a maintenance engineer, I need to fix a problem on a pump or compressor. So I know the tech ID, but now what are the relevant drawings I need to use to fix it, to find out exactly what are the connections, how it's linked into that environment. And often that is poorly maintained. So that's a big problem. Sorry, where a lot of time is being wasted. You see, example of PNID is a piping and instrumentation diagram. If you're familiar with manufacturing, you're very familiar with these PNIDs. It gives you the flow diagram on a factory floor. Where are your engines? Where are your belts? How is everything interconnected? And they are critical. They are critical components, and I'm going to explain to you in a moment. Examples of electrical drawings. At the top line, at the top left corner, you see the native drawing, and on the one below, you see when we did the scanning of these drawings. Because what we do, we scan these drawings for tech IDs. For every drawing we find, we're using AI to find what are the tech IDs being used on this drawing, and we store that information in the tech register. I'll explain that in a moment. The same for instrumentation drawings, same story. The same for safety drawings, same story. So what we do in effect is what you see over here. And what we do is really on the left. On the left you see the digitization and scanning engine. What we do over there, if you have a platform, if you have a manufacturing environment, you will have thousands of drawings to represent the factory. You will have your electrical drawings, your safety drawings, your cabling drawings, your instrumentation drawings, your PIDs, you name it. So you have thousands of drawings out there, which are being stored normally in the green part in your engineering drawing management system. But what you don't have, there's no clear information, okay, which tech ID is being kept or maintained in which drawing. So which drawings are being used to maintain all information about a certain tech ID. That information often is lacking. That link is not there. So what we do with the scanning, the AI-driven scanning of these tech ID, these drawings, is to find out all the tech information and store it in the tech register. So in the tech register, you find for every tech entry, every tech ID, this is the relevant electrical drawing, this is the relevant instrumentation drawing, this is the relevant cabling drawing, this is the relevant safety drawing, you name it. So there's up-to-date information because we have scanned that and we put it in that environment. We also scan the PIDs, the pipe instrumentation diagrams, as we do with drawings, and we also digitize them. Digitize means we break them up in each individual component and store that in your knowledge graph. So in your knowledge graph, in your graph database, you have your PID fully digitized. So you find over there for every component how it's linked to the next component. And then you can use that information which you now have stored in your knowledge graph and your tech register to go to the right. You find your GenAI assistant, your Microsoft Copilot. You can ask any question. I want to know what pumps are in this. What are the pumps in this PID? I want to know how is this pump connected to that pump. I want to know any type of information about a drawing. So I can all use that with a Copilot environment, or the TechQuest itself also has a normal search engine, because the DiagramIQ has a user portal, and from the user portal you have all the options to load the data, and the loading can be done at drawing by drawing, or it can also be done at mass loading. You can take hundreds of thousands of files in one go, to load them all in one go, to scan them all in one go, load in the TechQuest, etc. So it is all about having a clear enterprise TechQuest where you have all the tech IDs with all the tech information, with all relevant up-to-date tech information, and then you have a good searching mechanism. You got the normal search environments. You got your Copilot to ask any type of question in native language. And of course, whenever there's a new version of the drawing loaded in the green bar, in the green box in your EDMS environment, and it can be any EDMS environment, we don't really care. Then of course we do a scanning of the drawing again and make sure that the tech ID is up to date. And we make sure that the information about the tech ID is also linked to the green bar again, so that we do not copy any drawings in our DiagramIQ. We just link to the drawings. This is a very important feature for any manufacturing site. And then the next one is about, okay, now I have all the data, I have my tech information, I have loaded all the data in my AccuPrism, now I want to visualize it. And one way of visualize the data is really using a 3D digital twin. We got choices over there. We can we support the KDR Cognitwin from Kongsberg, and we also are going to support now Capmatic, another digital twin, and we're also looking at supporting in the future a 2D digital twin. These are all 3D digital twins, meaning they are based on your laser scan, or if you are digital site, on your 3D digital drawings. So what's a digital twin? It's all about, it offers you a single interface, whether you're in operations, whether you're maintenance, whether you're engineering, you all use that same interface. That means also you all speak the same language because you all see the same information. And the information will be a 3D representation of your facilities. You can click then on your pumps or your compressors, and when you click on a pump or compressor, it will give you at that moment all the relevant PI data, your time series data. It will give you all the asset data, which may be kept in your ERP environment, etc. So it's an end-to-end story. All the data we collect from your OT space, from your IT space, from your applications, goes into your enterprise data in the AI platform and is available interactively in your digital twin. And of course, the digital twin can make changes to that data, which will go back to your data sources or goes back to your OT as an advisory set point. And here you see it can be used for predictive maintenance, for your OE, for overall equipment effectiveness, a very important indicator in your manufacturing space. It can be used for HSE solutions. And of course, we look at the sensors needed, we install the sensors, and you collect the sensors needed, and all the network capabilities, like do you need OpenCUA, do you need MQTT, do you need 5G, whatever you need to collect those sensors to that environment. So have that end-to-end story, collecting data, installing sensors, installing agents from an agentic AI point of view, and make the data visible and manipulatable in your digital twin. And here you see some more examples how we can make use of it. And here you see some particular examples about Capmatic. So Capmatic is an example of a digital twin we fully support and bring to the market in an integrated solution. It's important all the time to talk about that end-to-end story, from data to visualization as an end-to-end story. And here you see the same, and on the right you see two pictures of 3D representation of your facilities. This example, and this is very powerful. It's really based on laser scans. You have to make a laser scan of facilities, which is not very expensive. And of course, you can then with the digital twin also simulate shutdown. So you can really say, okay, how do I optimize the time I spent on the shutdown? In which order do I do what activities, so that they don't get into conflict with each other, etc., etc., etc. So there are many environments where you can make use of a digital twin environment. And then the next component we're going to talk about is enterprise semantic model, very important, and your ontology. And my Fabric IQ is really based on ontology to latest edition. Let's first talk about the latest. How do I come to an ontology? Why is an ontology important? An ontology represents the data with a business perspective. So if you look at the data via the ontology layer, any business person can use his own language to access the data, to manipulate the data. So ontology is all about making your data and your data layer available in a language, in terms understandable by any business person. So if you're talking about how to get to an ontology, step one, bring all data together in Microsoft Fabric OneLake. That's the AccuPrism I spoke about before. So that's the first thing you do. Bring your data, as we explained before, in your AccuPrism environment. So you got all data come together over there and make it accessible. Then step two, process and harmonize the data. What does that mean? Harmonize the data is a data contextualization. Maybe look at your data quality, look at medallion architecture, go from your bronze, silver to gold layer. So it's really aligning data sources, aligning naming conventions, so make the data consistent, available. And then create on top of that your semantic knowledge, your enterprise semantic model. It's not just a semantic model which you're used to use in your Power BI environment, but it's really an enterprise semantic model. It covers the whole enterprise. It sits on top of that. And then on top of that, you got your step 4, you empower your AI agenda, because now you have now you have your semantic knowledge, and on top of it you have your ontology, and then when you got your ontology, you're ready to exploit that ontology data, use AI layer. For AI, AI can then work. It can really use the data from a business point of view. Let me quickly show the various layers. So number 1, bring all the data together, either real or virtual, in your AccuPrism. In the case of Fabric, you got many means to do that. You got your mirroring capabilities, you got your shortcut capabilities. Mirroring means I really copy the data, mirror the data from your data source into OneLake, and then it looks as being fully owned by, fully accessible in the OneLake environment. Shortcut means I only mirror the metadata into OneLake, but the real data stays where it is today. But still, from a OneLake user point of view, from a Power BI point of view, it looks like that data sits in OneLake, but in reality it's not. And I'll skip these, but you can look at that at your leisure. So OneLake has many connections to either do the mirroring or the shortcut to bring the data together into a single environment. Why is it important? Because the moment you have that in OneLake, virtual or real, it becomes accessible to your ontology layer, it becomes accessible to the Power BI layer, it becomes accessible to the RTI layers, it becomes accessible to all the services available from a Fabric or Fabric point of view. And here you see some more examples of the type of links available. And you see that it's growing very, very fast from a Microsoft point of view. Also, in case of this example of an SAP connection, you have a bidirectional SAP connection without installing any code in the SAP space. So step 2 is really the data manipulation we spoke about before. It's really your medallion architecture and your data contextualization. Step 3 is really creating your enterprise semantic model. Very important. You know that, of course, from the Power BI terms, where you create your semantic model. Here it goes across the enterprise, across it includes all your data sources being used. And step 4 is really to start creating your ontology layer, and really create that layer, and then make it available, for instance, to AI, to Copilot, to agents, and what have you. And you got your ontology layer. So ontology layer is really, I can show you an example in a moment. It's really make the data visible in a language understood by the business. If you talk about ontology, it really has three, from a Microsoft point of view, it has 3 components. The blue boxes are the Microsoft product names. You got Work IQ, Foundry IQ, Fabric IQ. if I start with WorkIQ brings together all your unstructured data. So WorkIQ is all about getting all the learnings, the context, all information out of my unstructured data. So you're out of your Outlook environment, out of your SharePoint environment, out of your Dynamics environment. So that is one piece of input for your ontology layer. So all your unstructured data is also available in your ontology layer. Then Foundry IQ is all about creates the data really out of your all the data not accessible via Microsoft Fabric. Yeah, so you can still have data sitting in data sources which you do not mirror or do not shortcut to a Fabric environment, and then you're using the Foundry IQ is meant to curate that information and make it available again as input to your ontology layer. And then Fabric IQ is all about the data sitting in your Fabric environment, or it can be mirrored, it can be shortcut, it can be whatever. But that's really what getting all the relevant data coming out of your Fabric environment. D3, WorkIQ, Foundry IQ, and Fabric IQ are your basic building blocks for your complete enterprise context. But it gives you unstructured data, gives you all the data outside Fabric, and gives you data inside Fabric. And that is an input for your MCP, which is really your connection layer. And then, of course, you can use it for Copilot Studio. I can use it for many of your Power applications out there, Microsoft Power applications. I can use it for many different agents found in Pro Code. I can use it for no-code, low-code, Copilot Studio. So it becomes available in a language and is set up, understood by any business person. And on top, because you can have Copilot of also moving into autonomous operations out there. So this is really the structure and the building blocks of an ontology. I have let me go over there. I will skip these slides. I will show you. Yeah, before I go there, Microsoft has also announced in March of this year Fabric Planning, which is another building block. Fabric Planning is really helping you the future business planning of your operations. So all the things we spoke about so far is really about your current or your past state. With Microsoft Planning, you also include your future state. It's a full-blown business process running in Fabric again. So it's important for you to keep in mind because it will also help you for future planning. So let me now show you. This is a very simple example developed in-house. It's a manufacturing ontology. It's a manufacturing company. Our company producing drinks in many factories around the world and ships to customers out there. Here you see on the very high level diverse links, diverse data sources, and what happens with an ontology layer. All the data about unit cost, about what money is being spent where, because you have all the information, because you have the information from your unstructured data, you got information from all your data sources, and you got information from your Fabric environment. All the data is available at this level, so you can now start asking any type of question. Okay, what if I would halve the production in my production site in Italy? What would be the impact? These are the what if type of questions you can ask anywhere. So we will do in the next couple of weeks. We have a separate webcast purely talking about ontology, how to define it, and how powerful this is. You really need to look at this because it's a very important building block. And I've included another. This is a picture for Fabric IQ, where it also shows all the links over here based on the same use case. This is another picture to show the use case. Here you see what type of data we put in to create this ontology layer, so you get a full picture ontology environment. I just kept it for completeness. And the last one I'm going to talk about, if you talk about ontology from a manufacturing point of view, it can help you with your unit cost. It can help you how to optimize your production, how to split the production between your different sites. If you talk about unit cost, you can help you with the margins and see how you can increase the margins. So all these type of questions with a typical business person would have, you can answer with your ontology layer, and on top of that, your Copilot, your Power App environment, your agents, because you also can automate things on top of that. So you can have your agentic AI layer, your agent layers on top of that as well. That's really what we want to talk about today in this particular webcast. So it was really about the manufacturing space and what you can do for asset management. Asset management in a very broad spectrum, from collecting all the data, or you have all the information about the asset in your ERP environment, in your tech ID, how you present your asset out of your digital twin layer, how you can get information out of your asset with your semantic layer and ontology layer. So this is hopefully this was useful to you. Thank you very much for listening to this webinar. If you have any questions, please reach out to Acuvate, and I'm more than happy to help you at any time. So thank you very much.